In the last lecture, we learned the analytic function fz equals to u plus iv and the CR equation ux equals to vy and uy equals to minus vx. Then now, this lecture we will learn another function which is named as harmonic function and conjugate harmonic function. Let's see what is harmonic function and its definition. A function uxy is said to be harmonic if it is satisfy Laplace equation. What is Laplace equation? Del u equals to del square u by del x square plus del square u by del y square. We know that fz equals to u plus iv. Then u plus iv. We know that the CR equation del u by del x equals to del v by del y. And this equation we find out del square u by del x square equals to del square v by del x del y. And we know that del u by del y equals to minus del v by del x. And in this equation we find out this del square u by del y square equals to minus del square v by del x del y. And add these two equation, we find out del square u by del x square plus del square u by del y square, which is equals to 0. Now this equation is called Laplace equation, del square u by del x square plus del square u by del y square. And what is Laplace and what is harmonic function? If this Laplace equation satisfy, this is called harmonic function. And let us see an example. Let u equals to x square minus y square, and we find out del u by u equals to u square minus y square, x square minus y square, del u by del x, which is equals to 2x, and del v by del y minus 2y, and del square u by del x square equals to 2, and del square u by del y square minus 2. Now add these two equations, we find out del square u by del x square plus del square u by del y square, 2 minus 2 cancel out 0. So this equation satisfy the Laplace equation, and this is harmonic function. Now so this function is called harmonic function. Let us find out the conjugate of u. What is harmonic conjugate? Del square u by del x square plus del square v by del y square equals to 0. Then how we can find out v? Now we know that del v equals to del u by del x delta x plus partial derivative of v tends to y del v by del y dy. Now we know that del u by del x, we know that the CR equation del u by del x equals to del v by del y, and del u by del y equals to minus del v by del x. So in this equation we put del u by del x equals to del u by minus del u by del y. So minus del u by del y delta x plus del u by del x del y, which equals to del v minus del u by del y, which equals to minus del u by del y minus 2y, and del u by del x equals to 2x. So in this equation we put minus del u by del y 2y and del u by del x 2x. Now we integrate del v equals to 2 delta of xy plus c. So v equals to 2xy plus c. Now vxy is conjugate function of uxy. Let's see and find out the conjugate function of u and check it is a harmonic function or not. Let us see a question. So that the function u 2x plus 2xy plus 2x is harmonic, and find out the corresponding conjugate function, conjugate harmonic function. So given uxy equals to 2xy plus 2x, now del u by del x equals to 2y plus 2, and del square u by del x square equals to 0. Then del u by del y 2x, del square u by del y square 0. So in this function satisfy the Laplace equation del square u by del x square plus del square u by del y square equals to 0. So uxy is a harmonic function. Then we find out the conjugate harmonic function. We find out vxy. ux by del u by del x equals to del v by del y, which del v by del y equals to 2x plus 2y plus 2, and del v equals to 2y plus 2 del y. So now integrate this function del v and two side 2y plus 2 del y. So v equals to y square plus 2y and plus g of x. G of x, what is g of x? G of x is a function of x. So g dash x equals to 2x. So g of x equals to minus x square plus c. The vxy equals to y square plus 2y minus x square plus c, which is conjugate of uxy.